Hello, and welcome to EduAdvisor's webinar series, where we speak to industry experts and academicians of various backgrounds to give you key insights about what they do. I'm Josephine Ong, and I'll be your host for this session. Today, we have Professor Engineer Dr. Izam, who is here to share with us about the careers in engineering. Professor Izam is the Dean of the College of Engineering at University Tenaga Nasional and a professor in the Department of Electrical and Electronics Engineering. He has a PhD in Electrical Engineering from the University of Strathclyde, UK, and is a senior member of the IEEE Power and Energy Society. His research interests include power system steady-state analysis, application of artificial intelligence in power system analysis, and most recently, application towards realizing smart grid technologies. Before we continue, if you have any questions for Prof. Izam, do leave a message at the comment section and we'll get to it at the end of this. So how are you doing today, Professor?
Good, I'm doing well. Thank you for having me here today.
Yeah, it's our pleasure. Okay, so let's begin. To start off, Professor, maybe tell us a little bit about yourself. Which field of engineering do you specialize in, and how long have you been in this field?
Okay. Well, I started my journey becoming an engineer when I did my diploma. I did my diploma in engineering. Okay. Then after that, I went on to do my degree in engineering, specifically in electrical engineering. Then after that, I went further to pursue my postgraduate studies until I completed my PhD in electrical engineering.
Yeah. Okay. So total been a while long?
After SPM, it took me close to about 9.5 years of studying. Yes.
Wow. Okay. So why are you so interested or passionate about electrical engineering?
Okay. Yes. Interestingly, when I finished my SPM, I didn't know much about engineering. Okay. I always thought that it was a difficult subject. But after I tried to do my diploma in engineering, suddenly my worldview becomes different.
How so?
I noticed that engineering is not as difficult as what I thought. Okay. The perception to say that it is difficult is actually just in the mind, because when you actually try to understand how it works, everything will just fall in place and you can actually understand how it works. So that actually triggered my interest to actually learn more about engineering.
Okay. So of course you had like a basic interest in physics and maths as well.
Yes,
right?
yes.
That is like very crucial.
Yes, that physics and maths is very important. However, the other important element is to be inquisitive. You must be able to explore and willing to test yourself, question yourself, even question your lecturers, so that you can really understand what it is supposed to be.
Okay. Yes. So there are many disciplines in engineering. Maybe you could describe some of the major ones for our audience here. Yeah.
All right. Basically, engineering has a broad range of spectrum of specialty, but it goes back to the basic element, which is electrical, electronics, mechanical, civil, and also finally chemical. So this would be the basic engineering program, where it covers the basic fundamental of the broad range of engineering application that we have today. Then after that, you have the hybrid type of engineering program. Say for example, you have mechatronics. Maybe you can have a specific one, let's say for example, electrical power engineering perhaps, or maybe on control engineering perhaps. So those would be the hybrid engineering programs, where it tries to combine the basic fundamental ones to actually make the graduate ready for a specific type of work task. But in general, I think the most basic must still be there. The electrical, electronics, civil, mechanical, and chemical.
Okay, maybe you could describe what chemical engineering does, what civil engineering and mechanical.
All right. Okay.
Very brief.
So let's start with the smallest one.
Okay.
The smallest one means that it is something that you cannot see. That would be electronics.
Right.
So in electronics, basically electronics is something that you cannot actually physically see what it is. You cannot see electrons going through circuits.
No.
You cannot see voltage drops. You cannot see power consumption. All you know is you see the product of it, maybe your handphone working, your tablet is functioning. That is all you see. But behind it will be the basis of electronics engineering, microprocessor, microcontroller, IC design and whatnot. So those are the small, I would call it the mini micro type of engineering. You look at small things.
Okay.
Then you go a little bit bigger. The one a little bigger will be electrical engineering. You still cannot see it. You don't see electricity going through your house, yes. You don't see mobile phone signal flying around all over the place, right? If not, everybody will be very afraid.
Yes, terrified.
Terrified. So that it means that we are going at a much bigger scale. So that is what we call electrical engineering. So we look at bigger equipment. We look at motors, machines, transformers, transmission lines, and whatnot. Okay, then once you've gone through the power part, then you look at the mechanical portion. So the mechanical portion would now focus more on how do we design power plants, how do we design the machine itself, how do we design an efficient machine or an efficient container to store energy and whatnot. So that would relate to mechanical engineering, because it looks at physical mechanical stuff. So mechanical engineers, I would say that they will learn something where you do things that you can touch. Whereas electrical and electronics is all in your mind and your imagination. Okay. So electrical is something that, mechanical is something that you can touch. So you look at gears, you look at cars and whatnot. Those are mechanical engineering. Then you go to civil engineering. Civil will be something that you can touch and see, but it is actually outside. You talk about bridges, you talk about roads, you talk about even designing water flow and drainage. Those are actually civil engineering. You can even talk about traffic control, because there's a path in civil engineering where you learn about traffic control and traffic management. How do you handle cities, or how do you effectively design a city? So that will also relate to civil engineering. So those type of people will be the ones who are willing to go out, to go on site, do measurements, be in the sun or be in the forest to actually build stuff. So those are civil engineers. Then it goes to the other part, which is chemical engineering. So chemical engineering is more related to chemical areas. You're talking about maybe oil and gas, pharmaceutical, or maybe food industries. Anything that has a mixture of chemicals together and how do you actually manage them, that is where chemical engineering comes in. So in terms of the difficulty level, we cannot say that civil is the easiest, chemical is the most difficult, but it would depend on what is it that you learn and based on the interest of the person. You may have a person who probably wants to do mechanical, but whenever they see electronic circuits, they go blank. Or maybe you see an electronics person who can actually do microprocessor or microcontroller design, but whenever they see thermodynamics, they go blank. So it all depends on interest. Yes, all depends on interest.
Okay, yeah, I like that. I like how you explain, like in linear, how be more people or more students to join.
Now, in terms of determining which engineering area which is in demand, underserved probably means it's in demand, or maybe there's not enough people going towards that direction. Then we should look at what the industry is actually going towards now. So if you look at what the government is going towards, is now we are going towards Industry Revolution 4.0. We are looking into more automation. We are looking into more of things that you can get from your handphones, applications and whatnot. And we are talking about data on your fingertips. So a lot of those would rely on the basic backbone of electronics engineering per se, or maybe a bit of IoT elements. So I would say now a lot of companies now are looking for graduates who probably have good sound knowledge on IoT devices, smart devices, maybe data analytics, and also maybe a bit of handling big data. So to say a specific engineering program is maybe not fair, but I would say that the new curriculum of engineering now should have those elements in place.
Okay, so that's good to know.
Yeah.
Students who are interested, like they can just go to mainly electrical and
Currently, electrical electronics are currently there, but it's being overshadowed by maybe the oil and gas industries because oil and gas industries demand more mechanical engineers. So now it's like a who's progressing faster than the other.
Okay.
Yes, that depends.
Okay, so with so many engineering fields to choose from, how would you advise students to select the right engineering program, and what should they consider before taking a dive into
engineering?
Yes.
Okay. First thing about engineering is the student must be willing to explore. It's not about going to class and listen what the lecturers say and you just do. It's about you're willing to actually explore and discover new knowledge yourself. That is what we try to teach in the university, is for the students to learn on their own. Because we cannot teach everything. We only have 4 years to teach engineering degree. So, but in the process, we want to teach them to learn new things. So with that in place, then it goes back to their interests. What is it that actually make them interested to know more about engineering? Are they more interested to do on something that where you can actually hold, where you can touch? Then we can say that maybe it's not electrical, it's not electronics. That could either be mechanical or civil engineering. Then between the two, you maybe want to ask yourself, am I willing to actually go outside? Because civil engineers will usually go outside, they do site reading, site measurements and whatnot. Are you willing to go outside? And if that is what interests you, fine, then maybe civil is the best direction for you. But if you feel that maybe mechanical is something that you feel comfortable with, then you can go towards mechanical. Now, if you talk about electrical and electronic, now then that relates back to what is it that the person want to aspire to become. Now, a lot of misconception that they say that if you do electronics, you don't get professional certification. Some say that if you want professional certification, you must do electrical engineering. So that is not correct, because each of the basic engineering has its own professional certification. You have an IR for chemical, civil, mechanical, electronics and electrical. It's there. It's just that how and when will you use it? So usually professional certificate is when you want to actually endorse plans or do design. So that would relate more on M&E related activities. That would probably be mechanical, civil and also electrical. So that's why you notice a lot of people who go for an IR certificate will be from these three branches of engineering, because they actually do M&E, they design buildings, and if they don't have professional certification, you might worry buildings fall down, bridge might fall, right?
Yeah.
So we need that to give accountability to the engineers.
Okay, so maybe when it comes to okay, so how long would it take for students to become a professional engineer?
Okay.
So, and perhaps their professional certificate as well.
Okay. So let's assume that you have finished your SPM.
Okay.
So you need at least 1 to 2 years to do your pre-university program. It depends whether you do diploma or you do foundation. Then after that, you probably do your degree program. Typical degree program will probably be 4 years.
Yes.
So that's like 2 plus 4, around 6 years. Then after that, most importantly, after you graduate, you need to get yourself registered with the Board of Engineers Malaysia. That is very important. It's by law. So once you have registered, then you go and work. From day one after you register, then you need to actually collect your experience, your work experience, whereby you're supposed to have a logbook or a diary to record all your technical experience that you have compiled. Typically, maybe after 3 years perhaps, if you have collected enough experience, then you can sit in for the first level of professional certification. Then once you've passed that one, then you go for the second level, where you already have the authority to endorse plans and whatnot. So in all, I would say maybe 6 plus 3 plus another 2 maybe perhaps. So that's 9, 11 years.
11 years, wow.
It takes a while.
Yeah. So you need to make sure you choosing the right one. Okay, so when it comes to career prospects, Do you think engineering is a good degree choice? Like, do we need more engineers, especially in the local scene?
Okay. Now, for a country like Malaysia, we are a growing country. You still see there's development happening around us, especially as when I came here, you can see MRT sites here and there.
Yes.
So that means that it's a sign that there is a still need of engineers. You still need engineers to actually be on site to supervise these activities. You still need engineers to endorse designs. And in fact, the requirement for engineers is still there.
Okay.
It's just that we want engineers with some extra capabilities.
Okay. What kind of extra capabilities?
Now, typically, engineering companies, they do not want a bookworm. They want an engineer who are capable to actually express their ideas. They can communicate with their peers and also can actually communicate with their superiors effectively. No, to communicate is easy, but to communicate effectively, that's the most difficult part. And in addition to that, they should be able to be open to new technologies and be able to adapt. No, because we can't teach everything.
Yeah.
But engineers are expected to learn as they work. So that means if they see something new, okay, where's the manual? Study the manual, okay, let's try this, let's try that, and whatnot. So that is what we would expect an engineer should be able to do.
Okay, so a lot of soft skills as well.
Soft skills and also maybe self-learning capabilities as well. Yeah.
Okay, so they have to be rather independent.
Yes.
In their own.
Yes.
Okay, so maybe share with us some of the specific engineering jobs that are very in demand.
Okay. Well, if you talk about the construction industry, of course we do need civil engineers per se, because you need them to actually do design of beams and whatnot for buildings. And together with that, you will probably have mechanical engineers to actually verify the design is correct or not and to design certain part of the building. And together with that, you also need electrical engineers to make sure that power supply is there for the building. So in short, in any construction industry, you need the three.
Okay.
Civil, mechanical, electrical. So that's why these three are the ones that must have professional certification, and they are the one where you need to be really certified and ready to apply. As for chemical engineering, that would depend on the oil and gas industries. So I guess it depends, of course. Now I think the oil and gas market now is going up and down, up and down. So it depends. But the usual constant will be civil, mechanical, electrical.
Okay. So the core ones are still safe to say are very much in demand.
Yes, yes.
Okay. So what does the career progression for engineers look like? Will you be stuck as an engineer forever, like positions as engineer?
Now that is what people worry.
Yeah.
Because they do not want to become an engineer forever. Right? They will feel like maybe they want to have an aspiration to become a big boss of a company or whatnot. To me, it's possible. Because an engineer, I would say, well, I might be biased because I'm an engineer, but I would say an engineer is very flexible.
Okay.
You put an engineer to learn accounting, yes, they can do. I've got a friend who is an engineer, mechanical engineer, but now he's a chartered accountant.
Okay.
You put an engineer and become a businessman with an MBA degree, you can. You also have an engineer who can become a CEO of a company. For example, the previous CEO of TNB, Dato Sri Azman, he's an engineer by profession. So, to me, if you're an engineer, sky's the limit. It's up to you on how you want to actually chart your direction of life. But in any job spec that you take, your engineering knowledge can be utilized. Believe it or not, you will.
That's great. So after career progression, perhaps many of the young people are also curious if they can make a comfortable living.
Okay. In general, if you are a junior engineer as you start work in Malaysia, maybe your pay is between 2,000 to 3,000 ringgit for a start. It's not as glamorous as as maybe medical doctors or whatnot. But I think if you persevere for at least another 5 to 6 years, then your career progression will be much more stable, and your pay that you get will be more comfortable. And if you get to work with multinational companies, yes, you do get paid a lot. I do have friends who just started work for 5 years, 5 to 6 years, worked in a multinational company who's probably earning about 4,000 USD a month. But then again, there's a pros and cons. You get 4,000 USD, but you are just flung somewhere in all the stunned countries in the middle of the desert and do work. So there's a trade-off. That's a trade-off of things.
No pain, no gain.
Yes, yes.
Okay, so in all that, so how does an engineering graduate stand out among the sea of engineers? Like, what exactly do employers look for?
Okay. In my experience talking to potential employers, looking for graduates with good grades is there. Everybody who works hard will get good grades. But what makes a person different is how do you actually communicate. I think the soft skills and communication skills is very important. How do you portray the confidence? How do you I would say, share your ideas to your peers? How do you convince your bosses that this is the right way to do? That is very important. An employer wouldn't want somebody who's very good in calculating something but not able to express. It will be very, very difficult that way. And an engineer must be able to work with everybody, not just with engineers. They should be able to work with other fields, with lawyers, with accountants and whatnot. So what employers are looking for are adaptable engineers, which means that you give something to them, they will figure it out and solve it for you.
Okay, so you would say, like, if there are two qualifications, the one is like really good grades and one is average, but when you talk to them, they are very engaging. Would that one stand high?
Yes. In fact, there are companies who are not looking for flat students.
Oh, okay.
They are maybe looking for maybe CGPA of 3 students, but who can actually communicate well. It depends on what kind of engineer that they're looking for. If they're looking for people who just sit down in a room and do design every day, then maybe a 4 flat student is the best. But if you need somebody who will need to talk to clients, who need to present ideas, then maybe not the bookworm.
Okay.
But typically they want something which is well-rounded.
Okay. So I think we are nearing the end of the session. So let's just have a look at some of the questions that we have from the audience.
Okay.
Okay, so we do have quite a few. Okay, so we have a question asking, what engineering course should I study if I want to go into the sustainable energy field?
Okay. Interesting question, because that's the current trend now.
Yes.
A lot of people want to be green.
Yeah.
They want to think that they're doing green stuff. So sustainable energy now goes into a few fields of engineering. You can talk about electrical engineering, because you talked about the system and how do you integrate the sustainable energy components. And you can also look in terms of the mechanical engineering part, in terms of the design of the sustainable energy system. So sustainable energy or renewable energy systems are actually not a specific area of engineering, but it's an intermix of everything. But I would say that you can either be a mechanical engineer or you can either be an electrical engineer. That would probably serve the purpose that you have.
Okay, so the syllabus within the engineering programs itself would sort of encompass.
Yes. For example, where I come from in Unit 10, we do have a lot of elements of sustainable energy, renewable energy, where we teach our students on the basic elements, how do we do the integration, what's the current trend, and that in support together with we have researchers or lecturers who are really involved in research work related to sustainable energy. That makes the mix to be better. So that's why we are called the Energy University.
That's right. Okay, so we have another question. So, I think Karina says, I heard that work schedule for engineer is hectic. Is it true?
Oh, okay. I beg to differ on that, because I would say engineers still have life.
It's good to know.
I would say architects work harder.
Oh dear.
But then again, I may be biased again.
Okay.
It depends on, to me, in actual fact, it depends on the person.
Okay.
You have to decide on your own work-life balance. You cannot just be working all the time. You must have what my friend always tell me time.
Okay.
So to say that we work too hard, not entirely true.
Okay.
Yeah.
Maybe since you have many years of experience as an engineer, maybe describe your day-to-day tasks. Like how was it like?
When I was an engineer.
Yeah.
Okay. At that time, I was engineer in the transmission department at that particular time in TNB. Of course, I start work at 8, come in, meet up with my colleagues, and of course, meet up with my boss to know what's the work to be done for that day. Then that's straight to work, doing my simulation work and whatever that's needed, whatever data that I need to prepare.
Okay.
Then by 5:30, I'm back home.
Okay, so it's almost like a regular
Yes.
occupation.
Unless you work shifts. I think if you work shift, then that's different.
Okay.
Because let's say, for example, in TNB, those who actually take care of the national grid, national grid must be on 24/7, regardless rain or shine. So we have engineers who work around the clock. So they work in shifts, maybe in morning shifts or night shifts. It depends.
Okay, so I hope you got that. We have another question, but I think we have covered that about the pay rate for engineers. So to wrap things up, do you have any final advice for students who are looking to pursue a career in engineering? Maybe some secrets to success.
Okay. Now, for me, if you want to do engineering, the most important thing is you need to have the passion.
Okay.
Because passion is important. With the passion, you can actually learn anything that you want. The fact that I'm doing electrical engineering doesn't mean that I restrict myself to just electrical engineering. Sometimes now I have interest in looking at other things. I looked at civil engineering elements, I look at mechanical, I even look at IT, because now the world is all jumbled up into one. So passion is important. Secondly, you guys need to be able to decide what is it that you want. Once you know what you want, then that's the path you should choose. Because in anything that you do, if you don't have that passion, you might be able to pass through your degree, with maybe you can get your degree scroll, but after you graduate, you won't have the passion to work. So you've wasted 4 years, 5 years of study, of trying to get a degree, but not putting your heart into it. So that is very, very important.
Alright, so basically have passion and interest in what you do.
Yes.
Okay, so thank you for joining our conversation today. We hope that you have gained a lot on what you should do next if you want to become a professional engineer in the future. Do come back for more of our webinars. Have a good day ahead.